Output visibility point feature is the first of the ZVI and ZVT commands I wish to show you, but in order to demonstrate this properly I'd like to just go through a straightforward worked exercise which involves importing some off-the-shelf DTM data and also draping onto that some map information, and then we can identify an area where we want to establish some new development, and then we can do some ZVI and ZVT analyses. You will have, as part of the test data install, a folder called Test Data Ordnance Survey Open Data, and in here is an example of some demonstration data from the Ordnance Survey in the UK. There are 4 20 by 20 kilometre ASCII grid files, some bitmaps, and these bitmaps are street level mapping images, and there are some TFW files which are TIFF world files, and these have the same name as the associated bitmap that they come from, and they contain the georeference information for each of those bitmaps, and it's quite important to have that, otherwise you need to know what the coordinates are for each bitmap so you can input them manually. I'm going to begin now by creating a new survey, and I'm going to give it the same name as one of the Esri ASCII grid files that I'm going to use. Input, convert from a single Esri ASCII grid file Okay, so that's your 50 meter gridded DTM, and I'm now going to drape the imagery. So give the image position file a name, and then add all of the 8 bitmap files that are in that folder. And what this now does is extracts each of those individual tiles and places them in their correct location in the survey. And if we zoom in on a certain part of that, what we now have is a gridded data set producing a bald earth DTM model, and by bald earth we mean the terrain model without any objects on it such as woodland, buildings, etc. If we draw a long section through it, we will see that bald earth DTM. What we're going to do is position some wind turbines on this hill, and we're going to use the ZVI ZVT visibility point feature command to determine from where within this terrain model those turbines can be seen. The first stage is to create some objects that we can add into the LSS survey. And you can add these into your standard prototype and then use them every time, but I'm just going to create them new for this particular survey. I create a new point feature. The code has to start with the letter P because it's a point feature, and can have then 3 further characters. If I'm going to create a 40 meter high turbine, that's the kind of code I'm going to use there. So it's 40 meter turbine. I'm not going to worry too much about whether we're going to display levels, although the colour is quite important. I want to make it very obvious on the plan display. It's always worth thinking about making these features non-terrain. Now that becomes important if you want to add them above the existing terrain surface. What you don't want to do is drape the terrain model up to the base of the turbine if you're going to raise it above the existing ground surface. So it's always a good idea to make them non-terrain by default. I'll give it a height of 40 meters, and just if we view it in 3D view, I'm going to pick a texture. For 3D view purposes, I'm just going to display it in one plane, which will mean that it will always face the eye. Choose a symbol. and give it a symbol size. I can now insert that feature, P40T, at the current terrain level, and I go and place it there, place another one here, and then a third one here. So those features are inserted at ground level and they have a 40-meter height. Before I show you the output ZVI ZTV visibility point feature command, there is an equivalent dynamic query command called query visibility point feature. I select my nominated point feature, which in this case is P40T. I choose my eye height. Now the eye height is the height of a person walking around the terrain model. We wanted to determine whether they can see the turbines. We set the maximum sight distance beyond which we won't get a hit, and we can also adjust for earth curvature and refraction. And over a distance of 10 kilometers, the correction for earth curvature is equivalent to 7 meters vertical, so it's important to have that adjustment turned on. We can now move the cursor around the terrain model, and whenever we click it will attempt to draw a line from that position to each of those point features. Now it has drawn lines, but they're in white, and because we've got predominantly white background, I need to go in and change the display colors so that I can say that predominantly the screen background is white. Back into the command, and now when I click with the mouse it will draw black lines to the point features. It's telling me I can see all three, and in the bottom left hand corner you will see how many points are visible and what the maximum sight distance is to the furthest of them. We'll now go on to output ZVI ZTV visibility point feature. We're going to create a new survey. Let's call this 40-meter turbine ZTV. Again, we select the point feature. We choose the receptor grid interval. A general rule of thumb is that the receptor grid interval shouldn't be any finer than the data that you've thrown at the system. So I've got 50-meter grid of data, so I'm going to use a 50-meter grid interval. From an eye height of 1.6 meters, a maximum sight distance of 10,000 meters. And I'm going to give the results in two forms, both as annotation and also as X, Y and Z, and the Z will be the point counter of how many turbines are visible. So that'll either be 0, 1, 2 or 3. I will choose a text style for the number inside the coloured box, how much of the 50-meter grid is taken up by the box, so 90% will leave a little bit of a gap between them. If you make it 100, then there won't be any gaps between them. I can also include background colour ranges. 0 would normally be blank, and then say 1 to 2 will be one colour, and then 2 to 3 will be a different colour again. Let's just change that. I'm now being prompted to select the receptor rectangle, so that'll be 50-meter grid points within that user-defined rectangle. It's now performed the ZVI ZTV, and I'm now going to create a new survey from that data. Okay, so what we're looking at now are the boxes containing the number of visible objects. So we've got 3s, 2s, 1s, and then we've got some blank areas here where there's no visibility. We can place the map backdrop on there if we want. Again, let's go to background image. Let's go and browse for that drape file, and let's show the mapping as a backdrop. The only thing we can't do is make these boxes semi-transparent. We can make them completely transparent by not putting a coloured background there, but we can't make the coloured background semi-transparent. Okay, so that's one measure. The other measure is if we turn off the general annotation, but now just put the contours on there at say a ½ meter interval. What we're now looking at is a contour map of the number of visible targets. So it's like a thematic map, if you will. So the maximum level is going to be 3 and the minimum is going to be 0. So if you look in the bottom right hand corner, we're looking at the Z value. The Z value is the number of turbines visible. Ignore all the 0.174 etc. It's either 1, 2, 3 or maybe 0 if there is no visibility. Okay, but a better way of displaying that would be to use color height bands, and we can set the color height bands to represent the range of values we have, so from 0 to 3. What you might want to do for the zeros, if I say less than 0.001, I'm going to make transparent, which is that option there. That's better. We can now see where the gaps are. So this is where we have zeros, and then this is where the turbines were, which is why we've got such high values around here. I've talked all along about the fact that this data is bald earth data. So what happens if we want to add 3D objects into the terrain to act as mitigating features to affect the ZVI calculation? One such example would be to add this woodland. Now if you're purchasing LiDAR data, which may well be DSM, digital surface model, you may already have height data for tops of trees, etc. But if you're stuck with bald earth data, then you're going to need to add a height to these features in some way. And the way to do it will be to assess the height of the trees in this woodland and then create a surface feature for it. If I go and create a new surface feature, and I'm going to call this 10 meter W, so that's 10 meter high woodland. Doesn't matter what values I put in here. Okay, say it's 10 meters. I'm going to give it a green color, and the important bit is the height in meters, which in this case is 10. Because this is simply gridded data, I don't have any lines defining the edge of this woodland, which means that I need to go in and digitize a line around the outside. So I won't do the whole lot, I'm just going to do a small area. Let's follow along, roughly along that road. Clearly you would do this much more accurately than I'm doing. If you've purchased the vector data, such as the master map data, then this woodland will already be defined by a line. It may well be 2D, and you could drape that onto the LSS DTM, and then you would simply just have to define this area with a specific height, because it would already be coloured in. Let's just finish this off. Again, forgive me for being so rough with all of this. Let's just go in and create a shape, finish that. Okay, I'm just going to go back to the beginning now and do a quick link to close it off. Okay, I've created now a nice line drawing around there, and I'm going to add the 10 meter woodland surface by enclosure. And that's filled that area in. A section through that to XYZ. You will see there's the turbine on the top of the hill, and there's the bald earth terrain, and here is the woodland. If I now go into the query visibility point feature command and now just move the cursor around, as soon as I go into this woodland, in the bottom left hand corner it will tell me that the surface height at the selective point is greater than the eye height, therefore I can't see out of that woodland. Similarly, if I go behind the woodland, I now can't see it. But as I move further away from it, I then start to see the turbines again. So this is an example of a heighted surface casting a shadow on the ZVI ZTV. The other way of creating objects is to build up heighted link features. So as before, go into Configure Legend, I create a new link feature. So 10MW is a link feature. Meter trees, again, whatever colour you're interested in. Height 10 meters. You can give them the texture as well if you want to view these in 3D. The only thing I need to do is define a line style. Again, the line style is irrelevant really, but if I now add that link and for example add it, I don't know, around this farm here, and repeat the exercise, visibility here, but as soon as I get close to this 10 meter high barrier I lose visibility. Gives you an idea of what's available within this particular command, but I've also given you quite a bit of background information to enable you to add objects to your data and also to take advantage of the power of this particular command.